start with this paper. I'd say you have it's February March 2019. The first question is about electrolysis. ठीक है बाद I told you कि electrolysis is going to come. Now this one is that you're given. He's saying he heated it's molten zinc chloride, right? So what are the two ions that are present in zinc chloride? Molten, it's Zn2 plus, right? And the other one is Cl minus one. Now in molten state there is no water. So the positive ion over here is going to get attracted to the negative cathode. So in the molten mixture, the Zn2 plus is going to get attracted to the negative, and the Cl minus one is going to get attracted to the positive. Is this clear, Mahad?
Yes.
So what happens in electrolysis? On one side, the battery, this is the negative terminal, so the battery is providing electrons, and from the other side, the battery is taking away or pulling away electrons. So Zn2 plus, I mean the electrons, there's no place else to go. There's Zn2 plus ions in the electrolyte. So the electrons would eventually be gained by Zn2 plus. So your equation or your reaction over here is going to be Zn2 plus gaining two electrons to form zinc metal. And on the other side, you have Cl minus 1 ions. The electrode is surrounded by Cl minus 1 ions. So who's going to lose electrons to the battery? It's going to be Cl minus 1. And Cl minus 1 is diatomic. Remember, group 7 is diatomic. So there should be two Cl minus 1 and they should lose two electrons in total to form two Cl atoms, which are going to combine together to form a Cl2 gas molecule. Okay, is this clear, Mahad?
Yeah.
So now the first uh, answer is that this is the definition of electrolysis, that you break down a substance by passing electricity, or the decomposition of an electrolyte by passing current. So this is the definition of what electrolysis is. Then a Bunsen burner was used to heat the zinc chloride. Describe how a Bunsen burner is adjusted to give a very hot flame. Uh, so the air intake is opened, ठीक है, or adjusted. We can check how they're actually answering this. One second, let me like how much detail is required. I don't think any detail would be required for this. One second, let me open the. Maha, do you know that there's an intake for oxygen or air in a Bunsen burner? ठीक है,
Yeah.
that's. I mean, they've opened the air hole or the collar. That's what they're saying. So the air intake, that would, I think that should be fine. As I suggest, explain the expected observation at the positive electrode. So, do you know what the colors? Remember the colors of the compounds on the sheet. You have to remember that. So, what are the colors? What is the color of chlorine gas? So, is there any idea what's the color of chlorine gas?
Is it green?
ठीक है, it's a greenish yellow gas. So, just explain the expected observation. So, a greenish yellow gas is formed. ठीक है, Mahad, is the data sheet? Have you memorized the data sheet so far?
I have, yeah.
As I suggest why iron electrodes cannot be used in the experiment. Now remember, in electrolysis, you always used inert electrodes, which were made from two things. They were either made from graphite or platinum. These electrodes over here, they have to be inert. Otherwise, they're going to take part in the reaction. Inert electrodes, they're made from graphite, which is carbon, or they're made from platinum. So why is iron not going to be used? Now, the reason iron is not going to be used is because in the reactivity series of metals that we did, more reactive displaces, as a more reactive displaces less reactive. Okay, remember this, we studied this in the reactivity series. Now, iron is higher up. I mean, if you remember the reactivity series, it's K, Na, Mg. then it's Al, and Zn in Fe, Tk, and so on. Now the issue with iron is that iron is kind of high in the reactivity series. So the problem with iron would be that it's going to react. It's going to react if iron electrodes are used. Iron is reactive. Iron likes to lose electrons. So iron would form ions when it loses electrons. So if the battery is taking away electrons, and if this is made from iron, imagine the anode being made from iron. Now the battery was taking away electrons from Cl minus 1. But if it's made from a reactive metal would lose electrons and would start to form ions. 2 plus ions to be very specific. So suggest why iron electrodes cannot be used. It's only a 1 mark question. So you're going to write that. I think you should just write iron is a reactive metal and will react. And will lose electrons or would react. We can just confirm what's the answer to that. Just this iron is reactive, that's it. Or iron is not inert, that's also acceptable. The next part is what difference would the chemist observe at the negative electrode if aqueous zinc chloride were used rather than molten zinc chloride? So now he's changing it to aqueous. So Mahad, if you used instead of molten, if it's aqueous, what two extra ions are present in the solution?
H1 ions and OH minus.
So H plus 1 ions and OH minus 1 ions are also present. And now there's the rule of the reactivity series, which is that now there's not, I mean, electrons are coming in, but you'd have two choices now. It could either be gained by H plus 1 or Zn2 plus. So the one that is lower in the reactivity series, that's the one that actually ends up gaining electrons. So it's going to be H plus 1 because if you remember the reactivity series, H is really at the bottom of the reactivity series. So the reaction would now be, it's not going to be this one. It's going to be H plus 1 because it's diatomic, so you double that, gaining electrons to form two hydrogen atoms, which are going to combine to form an H2 gas molecule. So now the reaction is going to be this one. And the same pretty much happens on the other side. You have another series over here. Now there's two substances that might lose electrons. You have Cl minus 1 and you have OH minus 1. So if you remember the series over here, it's I minus 1, Br minus 1, then it's OH minus 1, and then there is Cl minus 1, and so on. So the one that's at the bottom is OH minus 1, and the equation for that is 4OH minus 1 would lose 4 electrons. You have to remember this equation to form water and oxygen gas. Okay? Is this clear to everyone? Sidra, is this clear? Saad, clear?
Yes.
Yes, sir.
I said, so now the question wasn't, I said the question was, what would you observe at the negative electrode? Now, he's not talking about the equation. He's asking, okay, what difference would you observe if aqueous is used? Observe means what you're going to see, not the equation. So what you're going to see is hydrogen gas bubbles. So that's what you're going to write. You're not going to even identify, you're just going to write bubbles or effervescence. Okay, the explanation would be that H plus 1 gets discharged instead. That's where you're going to write the reaction. That H2 gas is formed. Okay, Mahad, is this clear?
Yeah.
So what's the test for chlorine? I mean, it should be on your fingertips now. Test for chlorine gas.
Bleaches damp litmus paper.
Okay, so the test is damp litmus paper. And it gets bleached. So it gets bleached. So now the next one is the bottle of zinc chloride is labeled corrosive. State one safety precautions that would be used when, you're going to use gloves, right? Remember, that's the number one safety precaution. Gloves, although goggles are probably not necessary. These are probably the only safety precautions. I'm going to give you one more safety precaution. If I mean, goggles would probably not be the right precaution in this particular case. Maybe it's acceptable, but gloves would be the right one because it's corrosive. So you don't want it to be you don't want the liquid to be spilled on your hand. There's one other safety precaution if there's poisonous gases. So if you have poisonous gases, there's a thing called a fume cupboard. Now, a fume cupboard is, I said, what's a fume cupboard? It's a cupboard. It's a glass cupboard, uh, so that I can show you what a fume cupboard is. Or a fume hood. TK, it's just a glass so that no gases kind of come out of the whole thing if the gases being produced are poisonous. So just a few of the safety precautions. They've accepted goggles over here. Uh, so you just have two safety precautions. That's pretty much it. So the next one is you're being given a student investigated the reaction between two different solutions A and B of aqueous potassium magnate and C. So there's KMnO4 potassium magnate 7. You don't need to know the formula. This is what's happening. A reacting with C and B reacting with C. These two are the same thing. They both KMnO4, but they're different solutions, so they might have different concentrations. A burette was filled with solution A. The initial burette reading was recorded. A measuring cylinder was used to pour 25 cm cube of C into a conical flask. So C is at the bottom of a conical flask. So here you have C. The burette has your A. Okay, your A is in the burette. So you're adding A from the top. Solution A was added to the conical flask until the mixture just turned pink. The final burette reading was recorded. About 2 cm cube of the contents of the conical flask was poured into a test tube to use in experiment 3. Uh, the rest of the contents of the conical flask were poured away. The conical flask was rinsed with distilled water. I said the first thing is taking the reading. Mahad, what's the value? What is this value?
It would be 16.1 minus 1.1.
Okay, so your final bureau reading is 16.1 cm3. Always write it to one decimal place, and minus 1.1 cm3, and this gives you how much? 15 exactly. So you can see I'm not writing 15. I'm writing 15.0. Always write up to one decimal place for a burette reading. Anyways, the contents of the burette used in experiment 1 were poured away, and the burette was rinsed. The burette was then distilled with B. Now the same experiment is repeated. Now B is being added from the top, and there's A in the conical flask. Sorry, C in the conical flask. The same experiment 1 was repeated using B instead of A. What are the burette readings now? What is this reading?
31.9.
T gets 31.9. That's the final burette reading, and this other one is initial is what?
1.9.
TK. So I say your difference is going to be what? So what's the answer?
30.
TK 30. And you're going to write 30.0 cm cube. I say you don't in a table you don't actually have to write the unit if the unit is already given in the heading. Then it's understood that it's cm cube. Now, which solution of potassium magnate 7A or B is the more concentrated one? Now, this is the tricky part. Now, look over here. There's A being poured into C, and there's B being poured. Now B, the amount of B that was needed was 30 cm cube. The amount of A that was required according to the Burette reading was 15 cm cube. Can anyone tell me which one is more concentrated? I mean, A and B are the same solutions. They're the same compound, but one is more concentrated, the other one is dilute. Which one do you think is dilute?
B is dilute and A would be more concentrated.
Okay, because there's more of it is required. That means there's a lot of water in it. So this is dilute. And by what factor do you think is it dilute? Like it's twice as much. It's twice as dilute. I mean, the concentration of A is, if the concentration of A is X, the concentration of B is going to be half of that. Mahad, is this clear?
Yes.
So the answer would be A is more concentrated as less is required. Sidra, is this clear? Saad, clear hai ye baat?
Yes.
Yes.
ठीक है, मतलब कम चाहिए तो उसका मतलब है कि वो उसके अंदर ना बहुत ज़्यादा lots of particles are close together. तो more concentrated, so you need a lesser volume. पानी अगर ज़्यादा होता तो particles would have been far apart and more amount would be needed. So how many times is it more concentrated? Twice. 2 times. Right? Is this clear as well? Mahad, is this clear? Saad?
Yes.
So the next part is predict the volume of solution B that would be used if experiment 2 were repeated using 50 cm cube of solution C. तो वापस आओ उस पर वॉल्यूम ऑफ बी. अभी कितना सी यूज हो रहा है? आई थिंक इट वाज 25 cm cube. This mentioned in the. So if we double this amount, what would be the volume of B that would be required? What's the answer?
60 cm cube.
ठीक है, so it's obviously 60 cm cube. So predict the volume of solution B that would be used if experiment 2 was repeated using 50 cm cube. So the answer would be 60 cm cube. And how would you explain the answer? You just write that it's double the amount. Solution C is double the amount, so solution B would also be double the same amount. इसका वो देख लेते हैं कि बस double volume of C used, that's it. ठीक है, no detailed explanation. Suggest a practical problem that using 50 cm cube. अच्छा, now this one is a tricky, slightly tricky. Why would using 50 cm cube solution C would cause a practical problem? And how could this problem be solved? Mahad, Sidra, Saad, any idea? कि मैं फिर से वो problem बता देता हूँ कि he's using 50 cm cube of C now. So ऊपर से कितना Burette से add होगा? 60 cm cube would be added, right?
It would be way slower.
नहीं,
It would
but
take a
that's
lot of time to pour 60 cm cube of
नहीं, but you know what the capacity of the Burette is usually.
50 cm cube, I think.
ठीक है, it's 50 cm cube. So how would you pour 60 cm cube? ठीक है, that's the practical problem that you're going to face. ठीक है, is this clear? Saad, Sidra, clear है आपको?
Yes.
अच्छा, so the thing is, the Burette has a capacity of Burette maximum capacity is 50 cm cube. So what would be the solution? You use 2 Burettes. So to add 60 cm cube, use 2 Burettes. अच्छा, पता नहीं, it stopped. 1 second. So to add, I don't know why this isn't. My pen has stopped writing. Just one second. Give one advantage and give one advantage. The pen is not writing. Okay? Give one advantage and one disadvantage of using a measuring cylinder rather than a pipette for solution C. Pipette. What's the good thing about a pipette? Advantage.
It's accurate.
Okay, so it's highly accurate. Acha, this is working. The pen is not working. One second. Okay, it's very so like so it's very accurate and precise, and it only measures one volume. What's the disadvantage of using knee measuring cylinder? What's the advantage of using a measuring cylinder? Mahat, क्या होगा advantage?
You could put a lot of solution, maybe.
It's fast, it's quick. Okay, you can pour things very quickly. Disadvantage is it's not very accurate. Another advantage is compared to a pipette is that you can measure any volume. Like with the pipette, you're stuck. You can't measure if you're measuring 25 cm cube. You can't change the volume. You can't make it 30. Okay, so it's fast and quick, and you can measure any volume. Is this clear?
Yes.
Yes, sir.
The next one is Evo Salt Analysis. Okay. Now, NaOH, you're adding NaOH and you're getting a green precipitate. Which ion is this?
Is it chlorine?
Chromium.
With NaOH, you're getting a green precipitate. And let me open the data sheet. Just one second.
Would be chromium, right?
No, it's not chromium. I'll explain. Look at the data sheet. One second. If I have it, right. Just one second. Yeah, actually, I don't have it. Once. So you would what do you call it? Now the thing with chromium is hopefully it has नहीं गलत वाली है. It's not the updated one. Um, let me give me 1 second. मैं वो दूसरी वाली निकाल लूँ. Maybe in downloads. अच्छा हाँ ये. अच्छा this one. ठीक है, this data sheet जो acid basis salts वाली है. Here's this list of ions. So remember effect of adding NaOH. I'm going to write over here. वो क्या था green precipitate बन रहा था. Look for the green precipitate. So it's chromium is a possibility. Chromium 3 plus with aqueous NaOH is going to form a green precipitate. But remember, it's soluble in excess. There's another ion which forms a green precipitate, and that is Fe. So you have two options: either chromium 3 plus or iron 2 plus. Okay, so out of these two, remember you're testing. You just have to memorize these tests. ये बात clear है सिद्रा? साथ clear है? Mahat, is this clear?
Yes.
Yes.
Acha, so going back to the question, you're getting a green precipitate. So now they did not tell you whether the precipitate is dissolving. So there's a possibility that it could be chromium 3 plus or it could be iron 2 plus. I mean, that's a possibility. Now, in the next part, he's saying aqueous NaOH was added to the reaction mixture saved from experiment 1. Now, this is where you really have to think. What happened in experiment 1? He was adding potassium magnate 7. Now, where have you heard about potassium magnate 7? I mean, what does it do? Mahadi organic में भी किया था. What does it do? I mean, open the.
Sulfur dioxide.
Hmm?
The test for sulfur dioxide.
No, you can. It's a test for sulfur dioxide. That is true. वो किधर गई है दूसरी data sheet? अच्छा, this one over here. ये तो acid basis salts की थी. अच्छा, this one over here.
Oxidizing agent.
ठीक है, exactly. You have to remember that. I mean, this one. ये जो oxidizing agents है. You have to remember the two oxidizing agents that you have to remember. Maha, do you remember oxidation of alcohols as well? उसके अंदर भी KMnO4 use हुआ था. The potassium magnate and potassium dichromate, they are two oxidizing agents. And you also have to remember two reducing agents. One is SO2, the other one is I-1. Now, the thing is that this KMnO4 over here is an oxidizing agent. Right? Oxidizing agent का काम क्या है? It oxidizes substances. So it's chromium 3 plus or Fe2 plus. So if they get oxidized, I mean, this is after the reaction, right? So they might get oxidized. So oxidize का क्या मतलब है? They might lose electrons. So chromium 3 plus might lose electrons to form chromium 4 plus or chromium 5 plus, जो कि उधर given ही नहीं है. Fe2 plus might lose electrons to form Fe3 plus. I mean, I don't see anywhere in the data sheet that chromium 3 plus gets oxidized to and loses electrons to form chromium 4 plus. मतलब वो है ही नहीं. That's not even given as a possibility. So do you get this part? Okay, the reaction that was happening was with potassium magnate 7 and it was an oxidizing agent. तो वो जो भी mixture से save पीछे बचा हुआ experiment 1 के बाद, that is the same ion but now it's oxidized because it has now reacted with potassium magnate 7. So it's either going to be, it's going to have a higher oxidation state. So Fe2 plus का हमें पता है कि it forms Fe3 plus. If you look at the data sheet, so in the data sheet, the only ion that's given is, it's given Fe2 plus, and then there's an oxidized version of that also given, and that forms a red brown precipitate. So question can be यही है, it's forming a red brown precipitate. So this has to be Fe3 plus. Maha, do you get this?
Yes, sir.
ठीक है. क्रोमियम मैंने इसलिए हटा दिया क्योंकि क्रोमियम की कोई और ऑक्सीडेशन स्टेट गिवन ही नहीं है. तो मुझे क्या पता कि ये कौन सा टेस्ट है. ठीक है. सो Fe2 plus की given the higher oxidation state. So the conclusion that you can draw is that it is Fe2 plus. It contains Fe2 plus ions. That's it. थोड़ी बहुत statements और लिखनी पड़ेंगी कि how did you reach that conclusion? Because that's 1 mark. So that's 1 mark. और उसने कहा by reference to oxidation. So you have to mention how did you figure that out. Fe2 plus changed into Fe3 plus because of the oxidation with potassium magnate 7. That was acting as an oxidizing agent. चलो अगले पार्ट पे चले जाते हैं. ये क्लियर है? साथ ये क्लियर है?
Yes, sir.
अच्छा, अगला, two substances, solution D and solid E, were analyzed. Solution D was dilute sulfuric acid. Tests were done on the substances. Test on solution D. पहले ही पता है. We know what the answer is. We know that it's sulfuric acid. We know it's H2SO4. Anyways, complete the expected observation. The pH of the first, I mean, what's the pH of sulfuric acid?
It would be low, like 1, 2.
ठीक है. A strip of magnesium ribbon was added. Now, and a gas was produced and it was tested. So metal plus acid is going to produce what gas?
Hydrogen.
It's going to produce hydrogen gas. What's the test? I mean, it's tested. So what's the? I mean, remember, he's asking for the observation. Not you're not supposed to identify the gas. I mean, if you identify the gas, there's nothing wrong with it. Like, he's not going to give you marks for that. Okay. What would be the observation of the tests?
Effervescent.
It's going to be effervescence, but he tested the gas. Test for
It
gases.
pops with lighted splint.
So it pops with a lighted splint. Okay. So this it's going to pop with a. So it's going to pop with a lighted splint. Next is silver nitrate was added to D.
Say it would give us 3 points for saying pops with the lighted splint.
Then you might write effervescence. Just 1 second. Because it's 3 marks. I mean, write H2 gas, write effervescence, write everything that you know about it. Okay. Just to be on the safe side. So lighted splint pops and 1 mark for effervescence. Okay. It's a question of then write everything. Okay. If you have 3 marks for that. I said this one, silver nitrate. What's the test? What is silver nitrate used for? Where is silver nitrate? I mean, which test involves silver nitrate? वो यहाँ पे है. It's these tests. You add in these tests you add silver nitrate, right? So it's a test for Cl minus one, Br minus one, or I minus one, and you get different precipitates when you test them with silver nitrate. But D that you have is H2SO4. So you're not. I mean, you're not going to get a result because you don't have Cl minus one, you don't have Br minus one, you don't have I minus one. तो इस केस में no observations. Siddha, Mahad, is this clear? Saad, clear?
Yes.
Yes.
I said then you have barium nitrate. What's barium nitrate used for as a test? Look for barium nitrate. Here's barium nitrate.
Yes, okay.
So here's barium nitrate, and barium nitrate is used to test for sulfate ions. You do have sulfate ions in D. D is H2SO4. So you're going to get a white precipitate in this case. Okay. Then you have E, and you have no idea what E is. As a first thing, you're getting a white solid. So Mahad, what is this first thing? What information does it give you if it's a white solid?
That it's not from the, what is it called? It's from the group 1 group 2.
It's not a transition metal. Basically, it's not going to give you only transition metals are colored, like chromium is colored, copper is colored, iron is colored. The ones that are not transition metals are not colored; they are white in color. So then you have solid E was heated gently and then more strongly. So a white solid residue is formed. So I think he's decomposing it, but we're not sure. So there might be decomposition happening, but again we're not sure. Okay. Distilled water was added to the residue, and the pH of the mixture was tested, and you're getting an alkaline pH. So that means a base is formed, right? That means it's either an oxide or a hydroxide. Okay, so it's either an oxide or a hydroxide. pH 10 is, but we're not sure. This did not give us a lot of information. Anyways, hydrochloric acid was added to E. I said, when do acids produce a gas? With what? I mean, what are the reactions?
with a base and
Y-
carbonates.
I mean, with the carbonates, with a carbonate, they produce carbon dioxide gas. I mean, it's turned lime water milky, so it is carbon dioxide gas. So that means solid E is carbonate. Okay. We're not sure which carbonate, but we know it's a carbonate. Okay, Mahad, clear है?
Yes, sir.
I said this particular paper has a lot of salt analysis questions. I said here you have distilled water was added and the mixture was shaken and NaOH was added and white precipitate was formed which was insoluble. So now he's adding NaOH. तो वो अभी NaOH का test देखो. What happens when you add NaOH when you get a white precipitate which is insoluble? So the first one, it can't be aluminium because it's soluble. It can't be zinc because it's also soluble. So the only one that's insoluble is this one, right? Is this clear?
Yeah.
Yes.
Acha, so that means this is going to be calcium. So it's a carbonate and it has calcium. So identify the gas, that's carbon dioxide, ये वाली gas. What conclusions can you draw? It's calcium carbonate. ठीक है, 1 mark for I think calcium, the other one is for carbonate. Is this clear?
Yes.
Yes, sir.
Then we can move to the last question was about the experiment. We can plan that. The rate of reaction between magnesium and hydrochloric acid can be followed by measuring the volume of hydrogen gas produced. Plan is an experiment to investigate the effect of decreasing temperature on the rate of this reaction by measuring the volume of hydrogen produced. You are provided with magnesium ribbon, common laboratory apparatus. You are advised to draw a label diagram. So mic किसी का on है. अच्छा, तो this is the label diagram that you're going to take a measuring syringe. You go say it's Mg plus I think HCl. So it's going to produce MgCl2 and H2 gas. So the H2 gas produced होगी ना, that is to be collected. What you have to do is you have to alter the temperature. How can you alter the temperature? Put this in a water. Put this in a water bath with a thermometer, and you can have a Bunsen burner at the bottom, and you can maintain a particular temperature of this water bath. Actually, you have to decrease the temperature. So not a Bunsen burner. You have to investigate the effect of decreasing temperature. So you can add ice to it. Mahad, is this clear?
Yes, sir.
And you can drop the temperature and see how fast the reaction is. So you're going to time it using a stopwatch. And you're going to see how quickly hydrogen gas is produced. So it's we can read what's written over here. So this is the आखिरी question. We can read this. Okay, the first mark is about the amount of. Remember, everything has to be kept the same in the experiment. When you're doing a fair comparison, the only thing that you're investigating is what's going to happen to if you decrease temperature. So only that should vary. Everything else has to be constant. The same volume of hydrochloric acid and the same concentration of hydrochloric acid has to be used in every reaction. The same amount of magnesium has to be used in every reaction. फिर वही वॉल्यूम भी फिक्स होना चाहिए. Gas syringe, we did this. Use top clock timer to time it. Measure volume of hydrogen gas at fixed time intervals. Repeat using different temperatures and compare results. डायग्राम के ऊपर इतने मार्क्स नहीं दिए जो कि होने चाहिए थे कि हाँ मतलब मेन चीज तो उन्होंने कही नहीं है कि how would you change the temperature, so that's they actually did not give marks for that. ठीक है. Mahal, is this clear, this paper?
Yes, sir.
Try and practice more salt analysis. ठीक है.
Okay.
चलिए ठीक है, विल कंटिन्यू विद दिस, बल्कि नेक्स्ट टू एक दो क्लासों में भी ना हम यही करेंगे, ठीक है? चलिए सही है, ओके देन, टेक केयर, अल्लाह हाफिज़।
Allah Hafiz.